There is recurring debate about whether down is hydrophilic or hydrophobic. And technically the answer to that is it's hydrophilic. A plume of down, when you get it wet, it will soak up that water and lose loft. However, when you take a bunch of down and you put it into a chamber like this, there are scenarios in which it seems like it's hydrophobic. And maybe in that case it actually is hydrophobic, when you consider the total of a lofted down chamber. So, for instance, we can take this bag of 900 fill down, untreated 900 fill down, and we can plop it in the water, push it under the water. And it's still at full loft. And when we open this up inside, the reason for that is really all that we've done is get the shell wet, get maybe some of the down on the very outer surface wet, but all that down in the middle there is still 100% dry. So let's do that again. Fully dunked under the water. Yeah, again, totally dry. So that test kind of mimics the scenario, like the catastrophic wetting scenario where you fall in a creek or whatever, and your down, gets exposed to a bunch of water all at once. And in that scenario, down gear is actually really pretty hydrophobic. It doesn't really, it's difficult to get a down chamber wet. And the reason being that this bag of down is trapping a whole bunch of air, and all that trapped air inside of this chamber is essentially serving to keep the water out of this chamber. Even if you dunk it under the water, if we were to dunk it under the water and then squeeze all of the air out, well, then we would have wet down. Totally flat, no loft. This thing would take forever to dry. Let's repeat that little test we did with the previous bag. This one is totally closed, so we can do this again. This is a chamber of untreated 900 fill power down. We can dunk it in the water, get it nice and wet. And as you can see, we've done exactly the same thing. We've just wetted the chamber material on the outside. The down inside is still totally dry. Slightly wet on the surface, but within the loft of the down, it's totally dry. If you were attempting to really get down wet, what you need to do is you need to put it in the water and push all of the air out of the chamber. Now that is wet down. Completely flat. No loft. No insulation, no R value. Now let's take a look at the same test with synthetic loose fill polyester. Same chamber, same material, different fill. So we can dunk that in there, do the same thing as first scenario with down. And again, of course, same scenario. This loose fill is trapping a lot of air, and you know, we can dunk it in the water, and the water really isn't going to go inside of that chamber too much because there's so much trapped air in there. If you want to really get it wet, you got to push it under and squeeze all the air out. So let's do that. All right, so that's loose fill poly, same scenario. It's definitely gotten a bit flatter, not as much as the down, which was just completely flat. But we've lost some loft. It's slowly kind of lofting back up. Yeah. That's actually almost back to full loft. All right, let's try this test with a piece of ClimaShield Apex. I don't have this in a shell, which would actually favor the other ones in a shell. This one, as soon as I put it in the water, is gonna there's no shell to hold out the moisture, so it's gonna soak it in right away. Fully saturated that. And that is kind of why you see that synthetic is a better option when it's really wet. This, you can essentially completely dunk this in the water, squeeze all the air out, get everything totally wet. You know, squeeze that moisture out, and that's pretty much that loft is mostly unaffected. And it's still wet. So alright, here we have our two test chambers, one on the left with untreated 900 fill power down, which we dunked and squeezed the air out of. And then on the right we have that same chamber except filled with the synthetic loose fill polyester. Also we submerged and squeezed all the air out of that one. As you can see, our down chamber is still totally flat, no loft, no insulation, or very little insulation at least. The loose fill polyester is pretty much back up to full loft, I'd say. And again, that's after really dunking it in there and squeezing all the air out, making sure everything is fully wet for sure. We can go back again and do this chamber again, just so we can see the whole process of how it lofts back up. So fully dunk that in, squeeze all the air out, really wad it up into a ball and get everything fully soaked. So now we can pull that back out and we can see after fully wetting and squeezing all the air out, we got that back up to pretty decent loft for being that wet. Certainly much more than this completely flattened down chamber. I'm gonna go back and do that and do the same process. Squeeze all the air out, squeeze it into a ball. So let's see if we can squeeze the water out of that and pat it back up like the other one and see what happens here. Yeah, we got nothing. That's flat. And how's our synthetic one doing? Yeah, that one's pretty much, we're back to, you know, pretty close to full loft. Still a little clumpy from being stuck together with the moisture, but you know, that's the difference. Yeah, big difference. All right, here we are back at the shop after our little adventure at the creek. It's been probably about half an hour, 45 minutes or so. And we can see our down chamber here on the left, which was dunked and squeezed and definitely gotten wet. It's still flat as a pancake. It's going to take a really long time for that to dry, and it's obviously lost all of its loft. Totally flat. And then our loose fill poly chamber here, it's very much back up to full loft. It was also dunked and squeezed and gotten fully wet. We did notice that for a short period of time it did show some loft loss, but after some draining and patting, it's right back up to full loft or thereabouts. And of course our ClimaShield Apex here, this doesn't have the advantage of having a shell, which it should for comparison, but that's actually an advantage to the others and not this. This was actually no shell, dunked in the water, squeezed, fully soaked. I mean, this thing, you couldn't even tell that it was wet, to be honest. It's full loft. It was, as soon as you pulled it out of the water, it was basically full loft. Almost no effect at all from the moisture. And then here, this is our bag of 900 fill untreated, which we dunked in the water several times, but we didn't. We dunked it and swished it and pushed it under the water, but we didn't squeeze the air out. And you know, as we can see, this down is fully dry still. It's we could weigh this and we would see that there was water absorbed into this system. However, it was all absorbed into the shell and maybe just a tiny bit of the outer parts of the down loft that got wet. But the down inside is fully dry still. So again, this is not the risk for a person with down gear, like catastrophic events where you dunk something into the water. That's really not the risk to the user. It's the accumulation of moisture over time. Since each of these plumes of down is hydrophilic, it will absorb water very readily. If you expose it to water over long periods of time, you will get more and more of this, where the plumes of down are soaked and there's no loft. Obviously, we've just shown that in short events, all of the trapped air in the chamber can make it act as if it's hydrophobic, but it really isn't. It's just that it's hard to get it wet in a short, isolated event. But it's very, very easy to get down wet in long-term exposure to moisture. You know, that can come from consistent shell wetting. Like if you're just walking in the rain all day and your pack, your sleeping bag inside of the pack is not in a waterproof bag, and that shell is just wet for night after night after night, you know, that will eventually soak into the down, and the down is going to eventually look flat like that. Similarly, internal condensation buildup does the same exact thing. It's just coming from the inside. The human inside of the sleeping bag is expelling moisture, and it will at certain temperatures it will condense inside of the down and cause the layer of down wherever that dew point is to soak up that moisture over a long period of time, eventually wetting out the down. So in summary, dunking a sleeping bag or a down garment into a creek is really not a good it's not a good depiction of real world scenarios in which you would be dealing with loft loss from moisture. In fact, it really doesn't even get down wet. So you're not really testing anything other than what a wet shell is like.